Namaskar Devi or Sajjano. Oh, I'm sorry. I forgot that I do this in English. It's been a while. Anyway, I thought I was done with the basics and everything else about Kubernetes, but now that I have read about many articles and people have written many emails to me about the possible splitting of Kubernetes and Docker, and people seem to be freaking out. So I thought I'll make another, bonus episode. Describing what's actually happening and telling you that you don't need to worry and that all is well. The first question that I will answer is, are Docker and containers the same thing? Docker actually popularized the container pattern, and it has been instrumental in developing the underlying technology. However, containers in Linux have existed for a long time. The container ecosystem has grown to be much broader than just Docker. Standards like Open Container Initiative and CRI have helped us with many tools to grow and thrive in the ecosystem. Some replacing aspects of Docker while others enhancing the existing functionality. Okay. And talking about container runtime, each container runtime has its own strengths and weaknesses, right? And many users have asked for Kubernetes to support many more runtimes. In Kubernetes 1.5, they have introduced the Container Runtime Interface, which is the CRI, which is a plugin interface which enables Kubelet to use a wide variety of container runtimes without the need to recompile. Part of the confusion stems from people using Docker to mean a great many different things. Inside your Kubernetes cluster, the container runtime job is pulling and running your container images. Docker is the most popular choice for that runtime, but Docker was not exactly designed to be embedded inside Kubernetes, and that causes problems. Docker includes many user enhancements for programmers, but Kubernetes doesn't really need any of that. The Docker engine that we install has three components: the command line interface, the API, and the server. The server in turn has components like container runtime, the volumes part for persistent data storage, the network interface, and Docker can also build images, right? It is the job of Docker shim to extract only the runtime, and this Docker shim is what is being removed. The advantage of just using the container runtime is that we don't need to worry about other components which we don't really need. We'll be using lesser resources, so for people using Kubernetes on the cloud, you'll pay a little less than what you would. The security risk is also reduced because we don't have to worry about components other than container runtime. Docker as an underlying runtime is being deprecated in favor of runtimes that use the CRI, that is the Container Runtime Interface, created for Kubernetes. Docker produced images will still continue to work in your cluster with all the runtimes as they have. If you are an end user of Kubernetes, not a whole lot will be changing for you. This doesn't mean the death of Docker, and it doesn't mean that you can't or shouldn't use Docker as development tool anymore. Docker is still useful tool for building containers, and the images that result from running Docker build can still run in your Kubernetes cluster. When Docker runtime support is removed in the future release, which is planned in late 2021, it will no longer be supported, and then you will need to switch to one of the other compliant container runtimes like Containerd or CRIO or Cryo. I'll just call it Cryo from now. Just make sure that the runtime you choose supports the Docker daemon configurations you currently have, for example, login, right? Will your Docker container still work? The answer is yes. The images produced from Docker build will continue to work with all the CRI implementations, and all your existing images will still work exactly the same. There's no change with respect to that. And container runtime alternatives include containerd, which was originally a part of Docker daemon, but it's been extracted and made it as a separate component. Amazon's EKS and Google's Kubernetes engine already use containerd as their container runtime. The other alternative is CRI-O, which is used by OpenShift. If you are just a Kubernetes user, you won't be affected as the container runtime is already abstracted away from you. If you are a Kubernetes administrator and you use AWS EKS or Google Kubernetes engine, then you don't have to manually install any binaries or current runtimes on your servers. So for this case, you don't have to take any action as your cloud provider will be taking care of it. But if you have set up a self-managed Kubernetes cluster, that is, it's you who manually installed everything related to Kubernetes on the server, you have two options. You can either substitute Docker with containerd or CRI-O. Your second option, if you want to continue using Docker, is that you need to manually install Docker shim separately inside the cluster. Docker shim, which was maintained by Kubernetes, will now be a standalone component maintained by folks over at Mirantis. So, like I said, containerd was actually a part of Docker. So they actually extracted it out and made it a separate component, right? Similarly, Docker shim was maintained by Kubernetes. Now Kubernetes will not be maintaining it, and people over at Mirantis will be maintaining it. So technically nothing has been, changed that much. Just the team who actually works with these components is different, that's it. So you don't have to freak out. Nobody's getting a divorce, and you as children of Kubernetes don't have to worry about your parents, right? Thanks.